So this is a sample rate multiplier. So the reading of sensor data is based on this one-shot clock. So this is set to 5,000 milliseconds. So when there is Bluetooth connection, the one-shot clock will start, and then when it expires, it calls this clock handler, which will pass this event parameter. So so, so what will happen is it will process that event, restart that clock again, and then call this perform periodic task, which will read the sensors and set the parameter. So what we want is to change this periodic event period from Bluetooth characteristics. So you can do that using util restart clock. So this one. So you can set your new period. So using util restart clock here, for example, we use the sample multiplier. So we use here, sorry. Here the sample multiplier variable. Right now it's set to 1. Then multiply it with SPP periodic event period. So we replace all the util start clock with util restart clock. So okay, so we set this to 0. So here, replace this one. So right now, the sample multiplier is set to 1. So 1 times 5,000 milliseconds is 5 seconds. So if we set the sample multiplier to 2, 2 times 5,000 milliseconds is 10 seconds. So we want to update the sample multiplier variable from Bluetooth characteristics. So okay, so we need to add code for getting the value from sample mul characteristics. So when you write to characteristics, it goes to that callback, which is here. And then it will pass this queue and pass this param ID, which will be in bar service sample mul car ID 3. So it goes to the main function and post up message. So it goes to here, process car value change event. And then we'll process the param ID. So case so good parameter. We get the parameter. So that's it. So we get, for example, we set 2 sample multiplier, and so there's Bluetooth connection, and then we set the sample multiplier value to here to 2. So this variable will be updated with value 2, and then now this will be 2 times 5,000 milliseconds, which is 10 seconds. So the sampling would be of the sensor data would be every 10 seconds. So I build this so there should be no build errors. So I rebuild all and flash the export to sensor to CC264 CRTF Launchpad with sensors booster pack. Okay, so I already flashed the X file, and the CC264 CRTF Launchpad with sensors booster pack is powered with AA battery. So right now the sampling rate multiplier is set to 1 times 5,000 milliseconds is 5 seconds. So 1, 2, 3, 4, 5. So if we set it to 0 to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now it's 10. So okay, so this actually is the challenge 1. So if the actual humidity is lower than humidity low threshold, the green LED will turn on. So right now the actual humidity is 83, the humidity low threshold is set to 80, so the green LED is not turned on. So I'm going to set this to 85. So now the green LED is on. So the actual humidity is lower than the humidity low threshold. So you can use this GPIO that turns on the LED to trigger a relay which would turn on a actual humidifier. So okay, so it works.